That's cool. I'm taking a look at YouTube. Let's wait a little bit. There's a 30-second delay, maybe. It's not live on YouTube yet,
Oh,
obviously.
we already have Peter in the chat. Our
Oh, we're
good
live.
friend.
We're live.
Yeah, we're live. Yeah,
Okay, let's get this started.
yeah, let's get going. Okay, yeah,
Hey,
people are
Peter. Hey,
pouring
Donnie.
into
Hey,
the chat here.
folks. So, yeah, maybe we can start sharing what's our plan for today.
Yeah, sure. So I think the plan is we're finally done with Elixir Patterns. It's been a long time coming. Thanks everyone for buying early. If you bought early, if you're just showing up now and you're thinking about buying it, appreciate you regardless. And yeah, I just wanted to talk about the book, talk about our journey writing the book, maybe what inspired it, and kind of what are our favorite parts of the book. We'll do some streaming of some live book notebooks, and maybe at the very end we'll drop a hint as to what's coming next for us.
Great, great.
Did I miss anything, or is that it?
No, I don't think that's all.
That's
Yeah,
it. All
yeah,
right, good, good.
that's it. That's it. And also for you guys who are already watching us, you folks, you can send us any questions about the book or maybe anything Elixir related or anything that we can answer, and we're happy to answer along the stream. So bring your questions as soon as you want. Um, okay, and yeah, maybe first part.
Yeah, so I can kick this off. I'll let everybody know kind of what was my inspiration for the book. Maybe you could share kind of how what drove you to partake in Elixir Patterns with me. So for me, I think I started reading the first was it Elixir in Actions first edition from Sasha Yurik. I think it was like 2015. And I think there was also another Manning book. Was it the little Elixir OTP guidebook? And so I started off with those two books back in like 2015, 2016 when I first heard about Elixir. And they're phenomenal books, great books, even to this day. I mean, Sasha Yurik just I think did edition number 3 very recently. So phenomenal books. But like over the years, I developed kind of my own patterns and things that I would continuously do in my professional settings. And I think after like 5 years of doing Elixir professionally, I kind of had a toolbox that I had put together myself. And these are things that I didn't see in other publications. So I figured after like 5 years and all these tools, I had enough to talk about it and write a book. So this was actually coming off of the weather station nerves book that I wrote. So I figured, it was good timing. It was good timing. So in this book, Elixir Patterns, we dive pretty deep into the Erlang standard libraries. Like the first two chapters, we go over like ets, dets, persistent term, the graph module, Q module, crypto module. So we kind of give you that foundation of tooling that exists in the Erlang standard library that people really don't reach for often, but is insanely useful, especially in a professional setting. Like for open source, libraries, stuff that you don't need to do kind of like crypto over the network or anything like that. Maybe you're not using it that often, but if you're programming Elixir professionally, you definitely need to know about what's in the Erlang standard library. And so in the beginning of the book, we go over those things to kind of lay the foundation and level set everybody. Um, in the middle of the book, we briefly go over the enum and stream module and kind of give our take on how you should use them and how you should kind of think about these modules. And then the later part of the book, and the vast majority of the book, we kind of go over how to structure supervision trees, common structures for supervision trees, how to conditionally start and stop things, dealing with error scenarios. So this is beyond what you would use in like a Phoenix application. This kind of gives you the tools to build really really complex things. And we adopt the pattern. I'm working on it, Peter. I'm working on it, Peter. That's my next publication, Elixir Test Patterns.
Adopting tests or something like
Done.
that.
Yeah.
For
Uh,
just for what it's worth, I in my Ruby days I wrote this book about TDD and BDD with Ruby.
mm.
So at least, yeah, I like that. So it's, but yeah,
Yeah. Not. I try to do a good job on the open source libraries on tests, but Peter has some insider info into some of my professional code. So he's sometimes you just gotta write the code and ship it, man. I'm sorry, Peter. I'm
yeah.
sorry. I'm sorry you have to deal with that, man.
But so and I say from my side, I think I've been working on the Elixir for a while. One of the things I've been doing in the community, and I had this idea of maybe creating some kind of new educational material. And I was, because of Elixir, I was reading Alex's blog a lot, and I liked the content very much. So I reached out to him asking if he wanna like join forces and do something together. The original idea actually was my idea was to build like small screencast videos about Elixir, but Alex got this other idea of maybe instead of like screencast, maybe a book. He had this idea about the patterns, and I really like it. And yeah, and there, here we are. And also, actually, another thing that I think is very cool about this book is that I don't know if it's true or not, but maybe this is the first Elixir book that used live books together with the book. So, as some of the people who are hearing us maybe know or not, I work in Livebook as well with the Livebook team, and obviously I love and I enjoy Livebook very much. So I brought this idea: what if we, instead of like sharing the source code of the book in like EX files, we share Livebook notebooks? And I think that was very the result was very good actually. We maybe can bring us to the other idea, and maybe we can share some of the, so working on this book brought lots of contributions to open source projects, even like book itself. So maybe you can talk about that.
Yeah, sure. Yeah, we can dive into some of those PRs. I actually really like those PRs. So I figured if we show them, maybe people would enjoy reading the code and stuff like that. And for these things, I did write tests, Peter. I'll have you know. So um, yeah, we can dive into some of the open source contributions that came out of writing this book. Because yeah, as we were writing it, like I would write things in live books. And I was like, man, it'd be really nice if, for example, I could see like if I could render the supervision tree in the live book. And I came up with something, very hacky and posted on Twitter. And I think, Jose sent me a message. It was like, hey, let's get this into live book. So I was like, cool, I could do that. So yeah, and actually, I think the live book idea was yours from the beginning because I was just gonna write the book, and then you said, hey, let's do the live book. So I think that was a huge win. Let's
Yeah,
see. All right, let me find my tab here of
if I
PRs that
could,
I found interesting.
yeah, I would even go ahead and suggest like everyone writing books about Elixir could. I think it's a good idea to have some kind of live books together as well. It's very helpful for someone to just go through the notebooks and play with the code very very quickly.
Oh yeah, oh yeah. All right, I think. All right, you could see my browser, right?
Yes.
Okay, cool. Yeah, so I have four PRs that I found that I would like to focus on that I thought were interesting. We'll start from simplest to most complex. Actually, in that case, I need to switch these two. We're going from simplest to most complex. But in any case, as I was writing the book, uh, like initially, it was just a giant folder of a whole bunch of notebooks, and it was a little hard to navigate them all. So I added support for anchor links when you're navigating across your livebook documents, and that's actually what gives like um, if you look at this video here, when you could have like an index live book and that lays out all your links. Oh, is it playing? Maybe it's such an old PR you can't even play these videos. Okay. It's a pretty old PR. In any case, you have an index live book notebook, and you can click on all these links, and then you can go in between them all. So you essentially have like one entry point, it's like your index.html, into your kind of collection of live book notebooks, and then you can navigate between all of them. And I'll show those in the as we look at some of the notebooks that we like. So this is one directly to live book.
I think
Really.
this one. I think this one. I don't remember if it like we had already or not. But for example, Dockyard Academy live books. They also use
Hmm.
like
Yeah,
links between a set of notebooks, so it's very easy to navigate between them.
yeah, yeah. Which I like. I think for content heavy live books, like this is a huge win, and it
Yeah.
definitely solved our problem of presenting these things in a good way. And as we can see from the date, we started working on this book a little while ago. So yeah, we'll ignore that. We'll ignore that.
Yeah.
That
No,
happened.
but for everyone working on books, I would say that like a year at least is kind of common. This is my second book. First one took 1 year. This one
Yeah.
is like set 2 years. Maybe usually it's more than we think it will be.
Oh yeah. Oh yeah. Yeah. And this one's a good size too. In printed version, it's I think like just over 300 pages. So
Yeah,
it's a full size textbook. Um, Yeah, this is one of my other favorite ones. So adding supervision
this
tree
is very cool.
visualization. So this one, it'll essentially traverse all of the children of a particular process if it's a supervisor, and it'll then build a mermaid diagram so that you can render your supervision trees right in Livebook. And so we use this a ton because as we're building all these patterns out, I mean, you can describe them with words, but the image here is worth way more than that. So definitely really needed this, and was glad that we can get it into Keynote itself. So that was another one of my favorite contributions here. Um, this one was a bit crazy. Wait, no, not render at stateless. Okay,
Yeah.
the next one's a bit crazy. This one's pretty simple, where we just took the work that was done previously, and in addition to rendering supervision trees, you could also render all the ETS tables that are owned by processes within that supervision tree. And you can see here from the labels, you can see which processes own particular tables and which processes inherit tables if something happens. So, like in this case, let's say the car auction cache dies, that process dies, this table will actually inherit the ETS table. Because as you know, that's um, the table has to be owned by a process, and if the process dies, all the state of the process is dead, but also all the data in ETS also gets reclaimed. So
Yeah.
that's why you need, like, if there's data that you really, really care about in ETS, even though it's a very volatile piece of storage, you can set up an error. And we actually, this is a screenshot of one of the patterns that we go over in the book, where we forcefully kill this process to kind of simulate an error, and we see that this process now inherits the table, and then when the supervisor brings up this process again, it actually pulls back the ownership from the cache error. So just different ways of dealing with failure scenarios. So yeah, that one was I really like this one too. This PR. And yeah, this was the crazy one, where once again using Mermaid.js,
Yeah.
we trace all of the messages going across all of the processes, and you can see what the messages are. You can see what they're who they're going to, and so this was again, it's one of those things where describing all these things in words, it's going to be very hard to kind of trace out all these things. Versus if you have a diagram that shows all the sequences across messages and processes, that becomes much easier to visualize. So we lean on this heavily in the live books, and I think I even incorporated some of the snapshots in the PDF, so you guys can see exactly what's going on, what messages are being passed around, how failure scenarios are being dealt with, and then that way you can kind of build this mental model as to how processes communicate on the beam.
Yeah. I remember that later after you contributed this feature, I think one of the very cool things about it is that it was very much related to the idea of Livebook itself, which was like making programming more visual. So it's different than a regular text editor. You have like is a web app, so you do have HTML, we can render and see visualize stuff. But then later, when I don't remember which version of OTP added the process labels feature, and I added like I added support for process labels on those diagrams in Livebook, and I had to read the code that you wrote originally to change a little bit, and I ended up learning a lot about tracing. So if anyone wants to learn how like what tracing or lang can be used for, this is a very cool example. Actually, I learned a lot just
Yeah,
reading that.
maybe can we put all the links in the chat in case, for
Oh
posterity's
yeah,
sake? Yeah, and actually,
yeah.
all credit, most of the credit goes to Jose because he walked me through, use this module in Erlang, do this, and then I just followed orders, and it worked out exactly as Jose said. So let me paste all these links here in case people are interested in how the inner
Yeah.
workings are put together. Yeah. So those are the kind of things that came from this, which is cool, right? Because you use a tool, you say, hey, it'd be really cool if this tool could also do this because it helps helps drive meaning or helps explain things better. So it's good that we were able to enhance this community tool by going through this experiment.
Awesome. So next, maybe we should we go through some parts of the book that we like it? Is it the next part?
Yeah, let me pull up the next window here and resize it so that it actually fits nicely.
Any news about? Oh, so there's a question here. Let me bring this question. So Spaceman 498 is asking.
Oh, you mean this one?
Yeah, yeah. So we have news about the hard copy of the book. Alex has been working on that, and yeah, you want to show it very quickly?
Yeah, sure. Yeah, so actually, so I have two copies on my desk. So going through print is a lot more work than PDF because the iteration cycle on PDF is 10 seconds. You build a PDF, it looks good, it doesn't look good, you move on. With print, it's like a few days to submit the print copy, and then you wait for the mail and this and that. So I think we have I think we have it. Like how we're gonna print it. Like the text looks good. Whatchamacallit? Let me get a good diagram here so you guys can see like how it looks in the book. There we go. Yeah, so we got like all the diagrams are printing nicely. We formatted all the margins. Like there's a lot of work that goes into actually printing a
Yeah.
physical copy of a book, but I think we're almost there. I think Hugo, you're getting your proof on next week. I think it's coming in. So once Hugo
Yeah.
takes a look at it too and gives me the thumbs up, I think we'll be good to go. And yeah, we'll be
Yeah.
going through Amazon KDPs. So I think anywhere in the world where you get Amazon, which I think at this point is pretty much everywhere in the world, you
Yeah.
should be able to pick up a print copy.
Yeah. Yeah. So the hard copy is coming. It's coming for those of you who likes paper. It's coming. Okay. Yeah. We were going to go through some parts of the book that we enjoyed.
Yeah, let's see here. Okay, so I'm gonna share screen again. How's the resolution on that? Should I enlarge it a bit, or is
I
that good?
think maximize the window is okay. The problem, maybe we need just increase the font size, but the window, we can use the whole space. I think it's better.
Oh, okay. All right. I think that you guys can read that, right?
Let's see.
Okay. All right. So showing off that first part, right, with like the navigation and whatnot. So this definitely makes writing books in Livebook much easier, where you can kind of navigate between all your documents, right? So you can go to this section. You can say, hey, I want to learn about system info. There we go. I find it. And then we can go back to the top and back to index. So it makes these Livebook notebooks kind of like one complete package, and you can traverse them pretty easily and find what you're looking for. So yeah, we definitely wanted to make it like a first class experience for the book. we didn't want the live books to be kind of like an afterthought. So we took a lot of time and effort into making sure that the experience here was top notch. So to that end, I think I picked one, two, three, four. I picked 4 live book documents that I really liked while we were putting this book together. And again, we'll start from simple and we'll increase in complexity to the last one. So one that I really liked is the leaky bucket rate limiter. So rate limiters, as the name implies, limit how much of something you can do in a given time frame. So like a common use case here is you have an external API that you're working with, and depending on what pricing tier you're on, you can only make 60 requests per minute type of thing. In that case, you need some way of rate limiting your requests. And there are open source tools that you can use, but sometimes you just gotta roll your own. A perfect example was I was writing an integration with an API. I can't remember who it was, but they had like a tiered rate limit. So it's like you can either make 60 requests a second, or like 1,000 requests a minute, or this or that. So you had like 5 different tiers of rate limits, and it was really complicated to use just an out-of-the-box library that could do that kind of rate limiting. So I had to write my own, and this is one of the patterns that I kind of came across. And actually, in the document, we kind of go over how would you make a dynamic supervisor with a registry. So you could spin up as many rate limiters as you want, and each rate limiting process gets its own configuration. And then that way, in this example, you have one rate limiter for Stripe, one for Mailgun, one for Telnix, which is kind of like Twilio. You send SMSs and stuff like that, and then Zapier, right? So a pretty typical setup in a web-based application.
I was going to mention that I think one thing cool about this diagram is showing that just for that. So if you're building a rate limiter like this one that we're showing how to build in the book, right off the bat, you're gonna learn about supervisors, registry, and dynamic supervisors. So I think like those patterns, they like a good excuses or good motivations to learn more about OTP and how to apply OTP to real world problems. And I myself, I didn't actually knew about lots of the stuff that was in the book because Alex was the one writing it and I was doing the editing part. And I learned a lot about all of different kinds of stuff that you can do with OTP. So yeah.
Yeah, and like you said, this is a super common one. So like maybe you're not building a rate limiter, maybe you're building something else. But this pattern of supervisor for kind of your component that you're putting together, and then a dynamic supervisor underneath it, and a registry. Like I've used that a million times. So like maybe it wasn't a rate limiter that I was building, but I've had to do that a million times. So having something that kind of walks you through it and you can just reference, it's like, oh yeah, how what's a good way of organizing these modules and naming them and processes and kind of what are the general helper functions that can be relevant to pretty much any use case. So do you want to walk through the code or do you want to just run the thing? I don't know. What do you think in there?
We can run the thing, but maybe there are some specific parts of the code that we also can bring attention to.
Yeah, sure.
But we can run, yeah.
Yeah, so here all right, so we ran all the previous code blocks. And over here, we start the rate limiter supervision tree, and then we also start each individual rate limiter underneath it. So these are all the rate limiters that we have. And as you can see, for every process that we start underneath it, we give it its own kind of configuration, right? So and these are just made up numbers, so don't use these as gospel for rate limits for Stripe, Shopify, Twilio, and Slow API, which is just a made up name. But it's more just to demonstrate that, for you write this one supervision tree and you can scale it as many times as you want, spawn as many processes as you want, and then each process does its own thing, right? So like the Stripe process is 60 times a second, Shopify 30 times a second, Twilio 120 times a second. So I think and this also showcases the ETS tables. So you have the the ETS table that the registry leverages. and then you have all the processes underneath that. And this is undefined is also the stuff that you added, Hugo, the process labels, which came
Uh,
in. Was that
yeah.
OTP 23 or was it 22? I can't remember.
I can't remember. One of the last 2 or 3 versions of OTP start to
Yeah,
support process labels to make it easier to
yeah,
debug and visualize the
yeah,
processes.
yeah. So yeah, undefined means we didn't set one. So we wrote these notebooks before that came out. So maybe we'll backfill
Yeah,
these later.
yeah,
But yeah, so with this supervision tree started now, we can make 20 requests, all happening essentially concurrently because we're just task asyncing them, and then we're not pausing or waiting on them. So if we take a look here, we'll see that all 20 requests, got shot out simultaneously. But now on the output side, everything's coming out, once a second. So 11, 12, kind of like clockwork, right? So we've now successfully rate limited all the data that's going through. And I think this is slow API because it looks like it's once a second. Yeah, okay, there you go. So you're saying, wait for turn. And the task is blocked until the gen server tells it that I can carry on. Uh, so in this particular case, it's also pretty interesting. Each one of these processes, so like the ones that you spin up, so slow API, for example, it's taking in the request. So this is a handle call. It's taking in the request, and instead of blocking the loop of the gen server, it's putting it essentially on a queue, and it says I'll do the reply later. And so that way it can keep on accepting requests without blocking outbound stuff. But then the calling process is blocked. And actually, that part's interesting. We could dive into
yeah.
that
Which
later.
yeah, the pods are interesting.
Yeah. So let's see. And again, that's something that you see often, but very very useful. So like here, let's see. Where is that happening? Okay, so a handle call. Usually, when you handle call, at the very end, you'll do a reply, and then you'll have the return value to the caller, and then you'll have the updated state. So you'll notice that this already looks odd because we're doing a no reply out of a handle call. But before then, we're capturing the PID over here, and we're putting it into our request queue. And then we have kind of like a cron job running that's flushing out the queue. And then what happens is in our pop request, this is essentially saying, okay, you're free to go. You can run your task external process. We pop the PID out of the queue, and then out of band from the original request to that gen server. Now we're saying, okay, let's reply to that server with an okay. So our gen server that's doing the rate limiting is not blocked by, let's say there's 50 incoming requests from 50 other processes. It's not internally blocked. It can keep doing its thing. But then every once in a while, it'll free up one of the processes, so it'll just keep sending messages whenever it's ready. And then that way, your processes aren't stuck in a pending loop. So this was an interesting one. I've done this a few times where you need to do work in your gen server out of band from the original request, and this is the only way to do it, since like once you're in some sort of a handle callback, that's it, it's atomic. The gen server can't do
Yeah,
anything else at that point. So
and
you need
and
some way
from
of saying I'll reply later, and that's how you do it.
yeah, and from the point of view of the client of that gen server, the caller, and it looks like synchronous sync work, right? They waiting for the reply, but the gen server is not like processing, stop it. They can continue to get new messages and reply whenever they have it ready.
Yep, yeah, exactly.
Yeah,
So it's, yeah, one of those things that you may not need it often, but when you do need it, it's ridiculously useful. And there's no other way out. Like if you need your
yeah.
your gen server to do stuff,
I
and you need to hold on to messages, there's no other way.
Yeah, I think for that specific like pattern of using gen servers, there's a very cool post and video from Herman Velasco as well. I think he posted on his Elixir Streams projects about making sync or async work look sync using that idea of no reply and then replying out of band with gen server as well. So if anyone wants to go deeper just into that part, there's a very cool and public post about that from him on Velocity.
Yeah.
There's
Yeah. So that's.
I'm
Huh?
sorry, I was just we're gonna bring there's a new question. This so Henrique ask it what was the biggest challenge of writing book.
Biggest challenge writing the book. So, here, you go first. You go.
Oh, uh, um, yeah, I'd say that. So one of the things was just maybe taking a little bit longer than we thought it would. So, um, and also finding a lot of the time to do it, because sometimes it's not like part of your regular job. But yeah, that said, um, yeah, that's how we took the time that we thought that we needed. So I think it's at the end it was okay. But yeah, and also yeah, no, that's for me. That's it for me.
Yeah, I was gonna say for me it was like the book itself. I very much enjoyed. There was nothing really I would say like challenging or difficult about writing the book per se. Yeah, for me it was an external thing. I think 2023, my wife got pretty sick, so I essentially like stopped writing for 90% of 2023, just to take care of my wife and my kids. So that was the hardest part about writing the book was not being able to write the book.
Yeah, yeah,
Yeah,
it happens. Yeah,
yeah. But yeah, luckily we got through that, and yeah, we were able to get to this point, which is 1.0, which is nice. It's a good feeling. It's a good
cool.
feeling. Yeah.
Okay.
Any other questions? Or
No, I think not yet. If
oh,
you have
okay.
many more questions, just shoot us, please.
Yeah. Okay. So one of the other ones that I really liked putting together was this section, and I think there was one. Yeah, this one's got one in particular that I really liked. So given that we're doing these live book notebooks, we were able to lean on very visual things like Kino, and in Kino we have access to Vega Light, so we can plot things. And one of the ones that I really liked was kind of showing I can do a ton of concurrent work ridiculously easily with the task async stream. And so for that one, yeah, this example just has a very very basic stress tester. So you can make a whole bunch of requests to an external URL or whatever, and you can see how long it takes to make all those calls, and you can plot them out. So yeah, again, we can dive into the code later, but I think it's important just to run it, just to see the lights blink. All right, so we'll run that guy, run this guy. Okay, so we see let me expand the screen here a little bit. There you go. So we can see our empty graph there. We'll send 10 requests to my blog. We should see those plot. There we go. So we got 10 things there. I think I was trying this last night just to make sure the demo worked, and I think I sent so many requests to my website that whatever firewall was in front of it blocked me eventually. But yeah, so you can see, okay, if I'm making 60 total requests and my concurrency limit is one, it takes 2.2 seconds roughly. Let's say we bump this up to 10 requests a second, or 10 concurrent requests, and we rerun the stress test. We see that it took way less time because we did a whole bunch of stuff all at the same time, and we can keep upping this limit, and we see what happens until we get blocked, right? Um, but this is just one of those things where it just shows you how easy it is to do a whole bunch of concurrent work in Elixir, right? So if we look down here at the code, all that form does is control, like for all intents and purposes, this value, right? So with that one value and task async stream, you can take a whole bunch of work and very easily split it up into a whole bunch of processes that tackle it all simultaneously. And so I just thought it was really nice where you can tweak the Kino form here and get different outputs depending on what you're putting in, and it just kind of drives that point home of, okay, this is the power that I have in Elixir, where I can do a whole bunch of work simultaneously just by spawning more processes.
Yeah, I was trying to remember which chapter this notebook was from, but
Uh,
it's
let's
it's the one
see.
about
Chapter
Process
4.
agents, yeah, chapter 4, yeah, yeah.
Yeah.
So it is about how one could use the task module for like building a stress tester, yeah,
Hmm.
using
Yeah.
the async string to do parallel work, yeah,
Hmm. Yeah.
in
And
Visual, yeah,
yeah, and I'll say like there are plenty of commercial tools out there for stress testing. There's even a whole bunch of open source tools for stress testing. But every once in a while, you just need to write something yourself because like there's a certain flow that you need to hit. There's a certain like sequence of API calls that you need to do where like your use case doesn't fit in the box of somebody else's tool. So you just need to write something yourself. It happens. It does happen. Maybe not often, but it does happen. So again, having these skills and knowing what to use and what to reach for is that's insanely valuable.
cool. There's another question here. So, what are our plans about keeping examples on the book up to date with new releases of Elixir?
Yeah. Luckily, Elixir makes this easy. It's not a
Yeah,
language where there's a lot of breaking changes. So, like, I think, like, we actually covered a lot of bleeding edge stuff in the book, right? Like, Partition Supervisor came out while we were writing the book, and we actually
yeah.
included Partition Supervisor in the book. Um, yeah, I mean,
I
I,
I would say that most of the content that we have is more leaning towards the kind of evergreen content.
yeah,
Um,
I don't foresee it going out of date anytime soon. Again,
yeah,
just 'cause we can count on Elixir being a very
yeah,
stable
yeah,
language and ecosystem. Then we're not using any libraries really throughout the
yeah.
web.
It's all
So
using what is in the standard library.
yeah. So I don't foresee this like in 2 years being like, oh, okay, I wouldn't read that book because it's not really useful. I wouldn't, that content doesn't necessarily apply. I've been doing these things for the last 6 years, and I imagine I'll continue doing them, right? Like leveraging task async stream, building supervision trees. Like that's just the way you have to program when you're using the beam. I don't see that changing very often. But to your point, Spaceman 498, like if there are new things that come up, or there's some tweaks to dynamic supervisor, tweaks to registry, and we need to cover those topics because they're important. Yeah, I wouldn't be surprised if you just go back to those particular sections, add some notes, add some additional examples,
Yeah,
and then whoever purchased gets like a 1.1 release email, 6 months from now, 8 months from now. So
great. Should we go to another part of the book that we like it?
yeah, sure. Yeah, I'll keep these. I'll keep these ones short because I think are we coming close on time? I'm not sure here. But
We
yeah, this
still
one.
have, yeah, still have 20 minutes.
Oh, okay. Okay. Yeah. So this one, again, I really like this one as well quite a bit because it really highlights the let it crash philosophy, which like I feel people say a lot, but don't like you can't tie something concrete to it. And so I really like this example because I feel like it gave me something concrete to say, okay, this is what let it crash means, right? So in this example, we build a work delegation supervision tree. So work comes into the webhooks manager. The webhooks manager throws that to the task supervisor, and the task supervisor throws that to another process to do the work. And the idea here is like maybe you have an API and you're sending out a whole bunch of webhooks for events that are occurring internally in your system. You need a good way of dealing with failure, right? Like maybe one of the endpoints you're supposed to hit is just down. Maybe they're doing a rolling deploy and it's just you just can't access their servers. You need some way of handling retries, exponential backoffs, and there's a lot of unknowns here. You're dealing with outside systems. You don't know when they're going to be up or when they're going to crash. So this is a pattern that I really liked with ingesting work, delegating it, and being able to handle retries and essentially any kind of errors.
It kind of reminds me of this pattern that there's this acceptor pattern, like for example, for accepting HTTP connections and that kind of stuff. It's kind of
Yeah.
not exactly the same thing, but it's
It's the
you
OTP take on that.
Yeah, you receive a request and then you don't respond at the request in the same process that received it. You delegate to another one,
Mhm.
and so you don't.
Yeah, and we were able to kind of simulate some of these error conditions by like, and again, this is all random, and you'll see at the very end how it all
Um,
successfully runs. Where sometimes we raise, sometimes we return an error tuple. So like this would be a what you call it? Like this is a condition where we can handle the error. We can return like an error tuple, or like this is we're in control here of the error. This is maybe somebody had a bug and didn't catch something. This is obviously never going to match. And then the other bit of the time we're saying, okay, our request went through. So we're not dealing with any real APIs, so we're simulating failure scenarios and success scenarios here. And so we'll just go down to the execution here. Again, we'll run that guy, and so this is the live supervision tree. So we have our webhooks manager and we have our task supervisors that are underneath this. The webhook manager will delegate the task to the task supervisor, and that'll again delegate it to the processes underneath it. So if we see here, we're going to try to send out a whole bunch of dummy webhooks, and we're going to see what happens. So we'll see that all simultaneously. We're sending out all the webhooks, and then under here we'll see all the output that occurred during there. So we'll see that, oh no, one of our webhooks crashed. We don't know what happened, and then successfully sent to 1, successfully sent to 5, 7. The whole bunch of 8 failed at one point, but then 8 succeeded afterward, or it resent 8 afterwards, and then we'll eventually see successfully sent to 8. So there's a whole bunch of work happening concurrently here. Each one of these tasks is dealing with sending webhooks, but then anytime a failure occurs, our webhooks manager is notified, and then they can retoss it back to the task supervisor after a certain timeout. And then if it's exhausted all of its retries, it can say, "Hey, we're just not doing this anymore. This webhook just ain't happening today." So, and again, like there's a whole bunch of craziness happening here. But again, at the very end, like if we search for this, we'll see. Hold on, we should see all of our messages went out. So we did. Oops, one. I don't think search is working here, but there's a lot of success here. Success, success, success. That's 1, 2, 3, 4, 5, 6, 7, 8, 8. And if I recall correctly, there are 8 total messages, right? 6, 7,
yeah.
8. Whew. Demo worked. The demo worked.
uh,
But another really interesting pattern. It may seem complicated at first. But it's like, oh, geez, there's a lot of processes here. But you only have to write this one. This one comes out of the box for you with Elixir, and that one takes care of doing all the spawning and delegating. So there's only one real module that you have to write. Everything else is given for you, and that's that's this one. So Webhooks Manager. Yeah, it might look long here because it's all annotated with tons and tons of comments. So you know what every single line of code is doing. But if you removed all the comments, you're looking at what 100 lines of code, maybe less. For some, that's a pretty complicated problem to solve, where you're sending webhooks, dealing with failures, dealing with retries, exponentially backing off. So it just goes to show you how much you can get accomplished in Elixir with relatively little amount of code. I couldn't even imagine trying to build this in something like Python. I wouldn't want to do it.
yeah.
But yeah, so that's not one of my favorites. And then this last one, the scalable actor model architecture with an S cache. Let's go down to the bottom. We'll render the live supervision tree. Supervision tree. Yeah, this one's got a lot of components to it, so it's good to kind of cover it. But essentially, we're the project in this chapter is let's build like a very performant auction system, right? So we have a car auction supervisor, and this contains all the cars that are up for auction, and if you're familiar with auctioning systems like eBay and whatnot, those are going to be very read heavy systems, right? Like you might have thousands of people looking at an auction, but what 1% might bid, maybe even less, like a quarter of a percent of people might bid. So the idea here is we need to tailor our application to deal with read heavy load, but still support pretty quick biddings, because maybe at the last minute or something you might have a flood of people trying to bid and sneak in and steal the item on a deal. So the idea here is we have a dynamic supervisor, and each one of these processes under the supervisor is going to contain the state of that particular item. So like this is one car, this is another car, this is another car that's being bid on. And this dynamic supervisor is initially hydrated with this initialization gen server. So this is the first gen server in the supervision tree. So it'll block all the other processes from starting. And then, or rather, it's the last one in the tree. So it'll block any subsequent supervisors from starting. And once all these other resources are available, it's going to go through and put all the data that we need in the dynamic supervisor. So any processes or supervision trees downstream are essentially guaranteed that this supervision tree has all the data it needs to run. It's fully set up and hydrated. We're good to proceed. So we have our registry, so we could look it up. We could look up our auction items by some sort of a UUID. These are all running processes, so we're dealing with bids atomically. So since these are gen servers, in our handle call, we're able to say, okay, this bid is greater than the current bid, so you are now the bid leader, or it's below the current bid, so you're not allowed to bid. And then we have an Ets cache, so any requests coming in that just need to read from the cache and not necessarily perform a bid are all going to get redirected here. And then we also go to the scenario where, let's say something dies in our cache. Like let's say generally a process that owns an Ets table, you keep very, very simple just to lower your surface area of problems that can occur. But let's say we're not heeding that advice and we do a whole bunch of logic in our cache, and that process dies. We need some way of restoring that Ets table so that we don't need to go, let's say, back to the database, find all the active items, rehydrate Ets, and everything is kind of on hold. So this is a good way to make sure that your Ets tables kind of survive processes crashing. So that should be running now, right? Yep. Okay. So we see we have a log message here that it attempted to restore the cache, but since that was the first time the supervision tree was starting, there's no cache to restore. And then we can kill the owning table. Oh, that's the restore. We have to kill it down here. Wrong code block. So we can see that this is the data before the brutal kill. So that before we brutally kill the Ets owning table, we'll see that we kill that table here. And given that the log messages are coming in out of order, we can see that we're getting data back after the brutal kill. And we also see before it died, it backed up the Ets cache, and it also restored the Ets cache. So again, a good way of dealing with failure scenarios using these. Like we just get all these cool tools out of the box. No libraries needed, just whatever OTP and Elixir give us, we can lean on. So I thought this one was really cool. And again, not stuff that you generally see, but stuff that I've had to do kind of in production in the past.
Yeah. And that one about about like when if a process owns an ETS table and it dies, and then you can transfer the ownership of the table to another process and then get it back. I found it very interesting because I wasn't aware at all about that. And then I thought that the OTP folks really thought about like handling failure, because not only you have supervisors like for restarting your process the way that you need to, you also like if you have state in memory, if as stable, it's kind of common. You can transfer ownership like we're doing here, and I think that's kind of exotic thing that's in there that most of people, I don't know most of, but lots of people don't know about it, and then now they can know how to use that when they need it.
Oh yeah, absolutely. Yeah. It's not something that's covered often, and maybe it's for a good reason. Where like maybe what caused the crash was what was in ETS. Um, so maybe you don't want to resource. Maybe that's why it's not talked about often. But like every once in a while, you need this lever, and it's good to know that that lever is there and you can pull it. And you just need to use it carefully. Was Uncle Ben say from Spider-Man? With great power comes great responsibility. So
Yeah.
use these patterns responsibly.
So
Um,
did we talk about all the parts that we wanted to talk to about?
I think that's all of them. Yeah, there's plenty more. These are just some of the ones that I
Yeah.
really liked. Like another one that I use often is I'll actually commit a lot of DETS files to projects that I'm working on. So they'll go into Git LFS, so large file storage. And when the application starts, it'll just take that DETS file and it'll just hydrate an ETS table. So like this is really useful for read-only data or data that maybe there's data that changes once a quarter, for example, right? There's no reason to put that in Postgres. There's no reason to take the network hit. Just commit it with the code base, bundle it into your Docker container, and then just hydrate the state of your app when the app starts. So like that one was really cool. I use that a ton. Um, yeah, we covered this one. We have the adapter pattern you could do with behaviors. Again, I think we gave it a pretty unique spin. Yeah, we can show it off here
Yeah.
really quickly.
There's
But
another one that's very common is the cron job. How to
yeah,
do a
that one's
cron
also
job with Gen server.
yeah, that's another common one. So I think there's like I said, like all these came from working in industry for a while with Elixir professionally, and they're things that I use all the time and I find very useful. And I think it was enough to put into a book, which is why we're here.
Yeah. We're getting close to the end. So we talk about uh so if you any of you guys didn't want to own a buy the book, we're still offering with discounts. So there are two URLs up here with just the PDF and EPUB or the ebook with the light books. We are offering with discounts until the end of Monday. After that, price is going up. So feel free if you wanna. And besides that, we were going to talk about the idea of this next project, right?
Yeah, I think that's the next thing on the agenda. Are there any more questions that we need to address, or are we all caught up on questions?
Let's see. Any more questions? If maybe not yet.
Okay.
Maybe we can. Yeah, we have a few
All right.
minutes. If any questions comes up, we can still answer it. But let's uh, let's
Yeah,
talk
we can.
about the next thing.
Well, let's chat about it. So I teased this a while ago, um, and I keep getting messages on Twitter, X, whatever. Like, is this still happening? This is very much still happening, and what call it? My older brother, who has a PhD in finance and economics, I was able to coax him into doing this with us because I finance is not my background, so I can't speak with authority on that topic. But what I can do is whatever he writes about, I can write code about it and show people, okay, here's all these financial topics. They might seem scary and complex at first, but let's break it down and write some Elixir code to deal with them and analyze, financial markets and various asset classes and stuff like this. So this book is currently underway. I think we're 40, 50 pages in. My brother has done a ton of writing on the finance side of things. And so this book will be leaning very, very heavily once again on live book because like we have a ton of financial and time series data. What better way to summarize it and visualize it than Kino and Vega Light and stuff like that. So this book will be making heavy use of obviously Livebook, Explorer, Scholar, and NX because we'll be dealing with a lot of data here. So yeah, I'm excited about this. Like
Yeah.
I can show off some of the table of contents. this is a rough outline. Don't hold us to this. But yeah, my older brother here was saying, let's talk about calculated risk and return in the stock market. I don't know how to do that, so I'll let you guys know. I figure that out. Constructing an index, is diversifying your assets worth it? Momentum indicators, volatility indicators, investor sentiment indicators. So lots of cool stuff that I know very little about. He wants to also talk about cryptocurrency markets. The nice thing about the cryptocurrency markets is all the data is public, so you just pull down all the blockchain data and you can analyze it. Some of the like stock market data, bond data, stuff like that. That's a little harder to get, but once again, we'll be pointing you in the direction of where you can get that data freely, and that way you can run all the examples in the book. Um, and then, I think he also goes through some real world scenarios where it's like, hey, let's take some of what we've learned in the book and let's apply it to the tech bubble crash of 2000, the real estate crash of 2008, 2009. So yeah, that's what's coming next. It's already
That'll be
underway.
that'll be a cool one. I don't remember if I told you, but I actually went to an MBA school like a few years ago, and was
Oh, I
mostly
didn't know that.
finance. Yeah, was mostly finance, and some of that I theoretically know. So
Oh, okay.
it's gonna be a yeah, it's gonna be a good reminder of actually how to do that kind of stuff again. Yeah.
Good. All right. So we have
I remember I really liked the like the derivatives, I think, or
derivatives.
the
Yeah,
futures. Yeah, it's very interesting. The math it's also very interesting.
yeah. No, yeah. I think he's gone through, and I'm trying to find
Yeah,
some
it's the
books on the page.
future
Yeah, there's a
market.
few. Yeah, like we got some very simple moving average formulas here that we talk about. Um, so it'll be nice to take an equation and then see some Elixir code behind it, and run it and say, okay, here's a plot of this moving average of Apple stock over the years, of Amazon stock, Nvidia stock, whatever. So it'll be nice to give again, teach everybody these tools, see how you do them in Elixir, and then kind of go out and do your own kind of analysis and find out some cool things.
Yeah. Before we wrap this up, I think there's one last question. So here is any examples of using the partitions partition supervisor in the wild?
Yes, we cover partition supervisor. Do you mean like in the wild? Like, do we have an example that we can point to? Like in open source or in the book? Do we have an example of partition supervisor?
Mm,
Mm.
yeah, maybe both. Yeah,
I'll answer both. I don't
yeah.
think we have any links to projects that are using partition supervisor in the book. Where we can, we actually do link out and say, hey, what we've covered in this book, like this pattern, is actually used like in Livebook, for example. Like Livebook actually makes use of like initialization gem servers. So we kind of point you in that direction and say, hey, look, there are other cool people using this too. In the book, I think I'm trying to remember the example for partition supervisor. For the partition supervisor, the example that we use is you're kind of ingesting a bunch of data and you need to do work on it. And I think we start off with a supervision tree where you just have like the supervisor and one child underneath it working and processing that data. And then we show you, okay, maybe this becomes a bottleneck because the data processing takes a while. Let's use partition supervisor to easily just horizontally scale this supervision tree with like minimal to no work on our end. And now, boom, we now have, depending on the number of cores on your machine or schedulers, um, you have that many supervision trees duplicated working on this. Or if you want to override the number of schedulers default config, to your heart's content, you can duplicate that supervision tree. So
Yeah. I think partitions provides us the one example of the things that usually it's not the usually, but there's a good chance that you don't need to use it on your regular web app. Because, for example, I think Phoenix is using partition supervisor behind the scenes. for scalability reasons. But it's depending on the use case. If it's not very specific, it's I think it's useful. Well, yeah. So, but definitely it's being used in frameworks like Phoenix, and I'm trying to remember if it using Lightbook itself. I can't, but it's kind of easy. Just go to GitHub and search for a partition supervisor and
Yeah,
see
I'll
if
say
there's any.
I don't think that's a pretty unique search term. I don't think you're going to find it in a lot of
Yeah,
like other code bases.
yeah.
Um,
But yeah, we 1 hour already, so
oh, perfect timing. We didn't even practice this or anything. Phew.
yeah. Let's like show the links one more time to
I'll stop
everyone.
sharing that. There we go.
So there are the links of the book. So those are not, you can share with anyone if you want to, but if you go to the website, links and pairs of that directly, the discount's not there. So you need to use those links that we have up here if you want to, or share with anyone. It's going to be valid until the end of Monday. And if you have any questions or comments or anything, you can find us on Twitter and Blue Sky.
Yeah, yeah, and you'll probably be hearing more from us soon as
Yeah,
the financial book content starts rolling out.
yeah.
So
Uh, that's it.
cool.
That's it, man.
All
2
right.
years, 2 years of work, and oh, super happy about that. Yeah,
Yeah, yeah. I'm glad we're able to deliver it in the end, even with all the roadblocks. I'm
yeah.
happy. I'm happy.
Thank you, folks, for being here with us. Then until next time. See
All right.
you.
Well, thank you.